The afternoon of FrOSCon Day 2 takes on. We've gotten one further talk, David Runge, Building a Secure Signing Environment, the Boring Infrastructure. Welcome. Yeah. Thank you.
Hi. Thanks. Yeah, so as we're looking into this topic, I would like to basically point out a few background infos about myself, about the project, about the context, about the state of packaging that we do, because all of this is Arch Linux related, and the motivation behind it, the project that we're working on currently, and all the future work that awaits us still. So a bit about myself. I'm a free software developer. I'm freelancing mostly. I'm also a Arch Linux package maintainer and developer, and I'm one of the 5 people doing the main signing key purposes basically for the distribution. Mostly focusing on Pro Audio, Rust, Python packages. I do a bit of infrastructure work all over the place. Also have been doing a lot of work on installation process in the past, but not so much recently, as I'm focusing more on infrastructure work at the moment. So yeah, let's start with the obligatory. Who in the room uses Arch? Oh, there's quite a few. It's probably half-ish until... That's great, because then I still need to do some introductory. Arch Linux uses the Pacman package manager that's written in C, and we do have makepkg, which is a script, like a bash script, that is used for package building. And these things are basically the essential core concepts of the distribution for all the packaging purposes. We do have a set of build scripts from which we build all of the packages that we have in the distribution. They're called PKG build. It's a specific format that has specific functions, etc. Most of this is used by DevTools, which is a project that is basically providing us with a collection of tools to build packages in a clean CH root, and deal with a lot of the surrounding things that we need. Some of that is also package signing. On top of that, we have DB scripts. It's also a bash project. It's quite old, actually. It's over 20 years old by now. And this is a set of scripts to maintain the binary repositories, and they are set up so all the packages go in and out, and all the transactions that go along with that. Being bash, I guess you can imagine how brittle that is. It's not a lot of fun working with it, but it is what it is. It is what we have right now. We do have a set of user repositories. You might have heard of the AUR. It's a platform to provide PKG builds, and you can share PKG builds, build packages from them, and it's basically a huge recipe collection, so to speak. A set of packages that do work in their free time. They provide others with unofficial user repositories, so those are separate from the repositories that we have in Arch Linux. And these are binary, so pre-compiled packages that are offered there. We have a bunch of AUR helpers that exist to basically streamline the process of building from the AUR, and some also for maintaining repositories in a rudimentary form. And I guess low level speaking, we need to understand what package repositories are actually. In a way, they're just a bunch of artifacts, pre-built packages. We have repository sync databases. If you want to know more about these concepts in a way, I recommend checking these 2 talks out from last year that I did here at FrOSCon and also at All Systems Go. And we have detached OpenPGP signatures for package files and repository sync databases. but as it's written here, it's optional. So you can, as a user, you can create your own repository, which would not have any signatures to verify package origin from, basically, or with. We have more or less artifact signing depending on the owner of the repository or us, the distribution, and the verification, on the other hand, is always depending on the user. The user can basically, if they wanted to, disable signature verification in their Pacman configuration and just say, whatever, I don't care, I'm just going to install whatever I get here. This is not recommended, of course. But yeah, just to say that this is somewhat optional, of course. There's like this nice mermaid I did. It's probably a little tiny. On the it basically outlines the interaction of the repository owner and the repository user with a repository. And as you see on the left side, the repository owner uploads package files and signatures, and then the repository sync database is generated for the new packages that are about to be added, for instance, or about to be removed, so that any user basically has an updated set of metadata and knows what to upgrade or remove. And the owner also creates the signature for the repository sync database, usually. But as that is on a specific host, that also means you would have to do that on that host, basically. And package files are usually created by the by the packager, and that doesn't have to be like the owner of the repository necessarily. But yeah, I'll outline that a bit more specifically later on. We have the repository user, on the other hand, that can receive like an OpenPGP certificate as an optional trust anchor, basically, or like a way of adding to an existing keyring to ensure that they can verify signatures for packages or repository sync databases. Basically, a user downloads the sync databases, optionally verifies the signatures for them, then derives like what packages to upgrade, and downloads the packages, and then verifies the signatures for those as well, and installs the packages. That's like the usual workflow that you do every day as an Arch Linux user, basically. The problem is, though, that the Pacman signature verification, the way we use it currently, is fairly brittle and limited. We have a system-wide mutable GNU-PG keyring in etc pacmand GNU-PG. It's sadly a very brittle setup because the state that we get in that keyring basically is mutable. So it is derived from other files that the user imports from, or the administrator of the system imports from, which means that this keyring can break, and if it breaks, then you need to reset it, you need to repopulate it, etc. It's a bit finicky, sadly. We do have a signature verification setup that is based on a PGP KI. You also know it as an OpenPGP Web of Trust. It's a very flat one that we have, though. We have basically a setup that is more akin to a CA, I would say. We have 5 main signing keys and a bunch of packages, basically, and we have a certain trust level that is required to be able to populate or to upload a package to the repositories. So a separate project is used to maintain this entire setup. It's called Arch Linux Keyring. You can check it out on GitLab there. It provides all the users with the trust anchors and the packager keys, basically. The downside of the implementation that Pacman chose back in the day is that it doesn't distinguish between different layers or different origins or different purposes for keyring, which means that the same keyring that that you have in etc is used for all repositories, and it's also used for all the metadata. So there's no distinction between the two or the three, basically. And yeah, that is sadly a downside, because you cannot separately populate several key rings and say like, oh, I only want these keys to be valid for the metadata, and I only want those keys to be valid for the packages that I get. So let's delve into a little bit of, well, the state of the package, the state of what we do and why we do it on Arch Linux. As I mentioned earlier, we have 5 main signing keys. These are basically trust anchors for the OpenPGP web of trust that we use. And this means that at least 3 signatures by distinct main signing keys are required to uphold the PGP-KI, because 3 signatures are required for each packager, basically. We have 64 individual package maintainers, so it's quite a few individuals, basically. They all have access to the extra repository. We have this trust level that requires them to have at least 3 main signing key signatures or identity certifications, and to be able to move any package into the repositories. 24 of these package maintainers are also developers, or in the role of developers. They have access to core. It's like a separate set of packages that always go to testing and are required to be tested, and are very specific. The Linux kernel is in there. A lot of the base utilities for all systems, basically. So our use of OpenPGP is quite diverse, I would say. We have upstream source verification that we do with it. We have package source verification, and we have as in tags in package source repositories on our GitLab. They're also checked before anything happens. We have the binary package verification that happens on the user side. We have deployment artifacts of all sorts with installation media, with virtual machines, etc. They're also all signed, usually by individuals. And we have, the repository sync database verification. Unfortunately, that is not signed. That is not so great. So we have a workflow in which packagers really build packages in a clean CH root, but that is all happening on a system, but not necessarily on a centralized system. It might be their own machine. It might be a machine that we provide. But there's not really a specific rule set around this yet. We encourage our packagers to use OpenPGP card hardware, because we don't want key exfiltration, of course, to happen. Each packager has access, due to this process, to the central repository server to be able to upload package files and signatures and, bump the process of please add this package to the repository or update the repository with this package. But as mentioned earlier, the sync databases that basically have the metadata of the repository are not signed yet. This is nonetheless something that Pacman can do. So the status quo is basically that one package maintainer has access to n build machines, their own, ours, and builds packages there, signs the packages locally, hopefully with a hardware token, and then pushes build packages and signature files to the repository server. We have, as I mentioned earlier, other artifacts, virtual machine images, for instance. They are built automatically in CI, and we also sign them in CI. The installation media that we provide monthly is actually built manually by a single developer and also signed manually, etc. And then uploaded. So there's sadly a lot of manual process going on here. We do have, yeah, as I mentioned, the CI pipeline, and we have builds going on in there that mostly relate to virtual machine images of all sorts that we provide. And they are also pushed to a repository server as far as I know, and then signed in CI. As you probably already observed, this means the signing key is also available in CI, which is kind of horrific. We have, building and signing of installation media. This is somewhat less horrific because a person that we trust, also with our packages, builds this installation media, then signs it, then uploads it on one of the build machines, basically. So this gets us to why do we want something like a signing enclave? You probably grasped already from like what I've outlined before. We have like lots of funny pitfalls in our infrastructure that is maybe not so nice to have. We want to fully prevent key exfiltration because currently we have a lot of packages, but we cannot really tell whether they use hardware tokens and whether they have been compromised by now or not. We have, private key material in CI that can or could be exfiltrated as soon as one of the DevOps is basically compromised. We have, then the need, of course, to basically have fewer systems to guard than the current plenty systems that we have. That's where we want to go. And preventing the key exfiltration by minimizing the systems where we actually have private key material available. Another big point is, of course, we want to automate everything. We have package build automation that people are currently working on. And we also want to have that for mass rebuilds. Mass rebuilds are in some way still very manual because of dependency cycles, etc. Every distribution has their own little set of scripts and tools around this. It's somewhat horrific if you want to get it right. And I mean, ideally, all of this should be happening on secluded infrastructure. So it is only triggered by someone that actually maintains that package instead of them manually or actively building on that machine, of course. We do want the signing of repository sync databases, of course. We want to close that gap. We do want automated building and signing of installation media because that is much better than a person doing that manually every month. And of course, also the secure signing of virtual machines. That's where Signstar comes into play. That's good in time. That's fine. So our basic requirements towards the signing service that we're currently building is that it basically has security in mind. It is maintainable by us. It is hopefully robust because boring, in fact, is good. Integration with existing packaging ecosystem is an absolute must because what we have currently we cannot, in all good faith, just kind of also revamp at the same time, of course. And we also want the standards compliant implementation of OpenPGP because that's what we're using at the moment. Let me just grab a drink. So the current threat model around this entire setup is that we have a hardware security module. I'll get to that after the threat model setups. And the HSM is, in our setup, hopefully a tamper-proof device, which then fully prevents key exfiltration, so that no one can just, take those keys and sign something somewhere else with it, or do some other shenanigans with it. We do want to ensure that the credentials that we use or need for administrative actions, they are basically usually stored offline, securely, and only used when reconfiguring the thing. That is for initial setup, for instance, or when something in the setups changes, like adding new keys, removing keys, adding users, etc. And this is already like a bit also leaning into the setup of actually a thing using the HSM and not the HSM itself, of course. Backups of the HSM should also be existing and stored offline and encrypted, of course. That brings us to like the host or the machine or the service that actually uses the HSM that we want to use and be able to make use of in an automation environment, basically. We have dedicated host, of course, and we want to have it manage all the access to the HSM so that it literally also is physically not possible to just bypass that host. The host should not be accessible actually during runtime through SSH for administrative purposes, because then you could have like some person that is compromised log in and do something with it. That's what we want to prevent, of course. We have the idea of, currently at least, I should probably mention that this threat model is still under development, is not fully done. And the two separate immutable read-only operating system things that we want to use for this, they can actually, in fact, coexist on the same host. I'll get to that in a little bit. But we want to have a setup like this to fully like segregate, like administrative, but also the signing purposes of the service, of course. In an ideal world, I mean, we would have like a very specific setup for actually changing the host, like a setup that is really loud, right? And our current idea is that like doing this in a rescue environment is actually like the loudest and setup thing you can possibly do, because the people that have administrative power over that host will know that this host is going down for rescue mode right now. And we're still not entirely sure about this entire setup or whether we can even work without that. That is still a bit on debate at the moment. In an ideal world, we would also want to have just credentials for the unprivileged actions. Those are like operator users on the HSM. They can do the signing and so on, to not expose any of these credentials to the outside world, because we, at least not the passphrases, for instance, the usernames, that's probably fine, but to completely separate that from the HSM and the outside, and just rotate it on each configuration change, because they never need to leave the host or the signing environment, basically. As mentioned earlier, we want to have backups, and they should be created after each reconfiguration. Once we have a breach, of course, of administrative credentials, we need to rotate our credentials, and everything needs to be reconfigured accordingly. I'll get to that, like the specifics of that a little later, in fact, because we are still a little unsure of like how to properly ensure this to happen in a clean way. Because there are multiple possible approaches to it. We have, as mentioned earlier, a mutable system that we are striving for, and those should basically be just given credentials for operators that then are exposed via a service to the outside world. So clients are then just calling in and saying, hey, I have this user I just logged in with, sign something for me. And we want that to be able to reconfigure it fast and transparently, and ideally also reproducibly, of course, for in the context of the OS images. A transparency lock integration is also definitely needed for this setup, because you want to not only know that you signed something because of a lock or whatever, but you actually want to be able to ensure that someone else saw that you created that signature. That's what the transparency log is basically for. The monitoring will take place outside of the context of this project that we're discussing right now. On the client side, we have, well, multitude of clients that can log in and are hopefully then properly configured to have their credentials towards the signing service, which is not the HSM itself, to be properly backed, like hardware backed, and potentially even service specific. So it can be made very hard for it to be exfiltrated, or even impossible to be exfiltrated, because there are certain setups for SSH, for instance, to use a TPM in combination, and then you could still use that host, but you wouldn't be able to just copy an SSH key to another host and use that to log into the service at all, actually. As you can imagine, most of these clients may be like build machines, so they run all sorts of stuff, all sorts of untrusted code, all sorts of funny shit that you're building. It's a lot of fun, but it's also unsafe, and it might mean that these clients get easily compromised. Compromised clients ideally are under our control. We can shut them down if we need to, but more importantly, we can just reconfigure the signing host to not be able to not allow them to log in anymore in a very fast manner. And key here is basically the transparency log also, and the full monitoring of this entire setup, of course, because otherwise you will not be aware of anything being off. So we've evaluated a few HSMs and ended up basically on Nitrokey. Nitrokey's NetHSM, as it is fully open source. It has an open source operating system. It has a documented API that is like OpenAPI docs based. We have an auto-generated Rust client that we can make use of. And on top of that, we have a container image that basically provides us with the operating system, but in a containerized form, fully allowing us to test against an API. We have custom integration for this. This is something I worked on over the last few months. We have a high-level, also fairly extensively documented library now that makes use of the previously mentioned Rust bindings, because those are really auto-generated. And if anyone has ever worked with OpenAPI generator, then you probably know that it's pretty ugly stuff usually, and you need to really make some effort to make that usable by actual end users. And that's what we're trying to achieve here, to make like a user-friendly library out of this that wraps around it. We have a dedicated command line tool that is literally able to interact with the full API surface, currently minus the namespaces. That's a new feature that still needs to be implemented. Also very important, in fact. We have now OpenPGP support, thanks to Viktor Kvapisevic. That's pretty awesome. It's still not fully done, but you can basically soon use the CLI tool to sign messages or anything really. I hinted at this a little bit earlier already. So the setup that we want to achieve is that we have a client or many clients basically, that allow us to log into Signstar, and then Signstar does something, and Signstar is the only thing that is allowed to log into NetHSM basically, and direct connection is not possible, either physically or because of net setups basically. This is maybe a little small still, sorry for that. This is a rather simplified view of this entire thing. We have envisioned like a user mapping that is done for the client user towards the signing service to use a user mapping towards the HSM, so that the user names are actually never really relevant to the client. The client only knows I'm connecting to that signing service. I want some stuff to be signed, and the signing service knows due to the logged-in user which NetHSM user to map to, and returns like a raw cryptographic signature for it. Yeah, this is a little more like in-depth for the signing part of it. As you see, we only have like need a pair of Signstar credentials by the client, and Signstar basically does the entire user mapping and maps that then to the HSM. Deployment-wise, this is a little more involved, as you can imagine, because we have many things to take care of. We want to ensure that the credentials used for setup of the HSM are safe and or not used entirely all the time, because they might not be needed all the time unless you want to reconfigure something. Yeah, this is probably easier to look at in the slides. There's a link later on. Suffice to say, we basically want to have a TPM-backed setup for the Signstar host that allows us to have R administrators and N administrators. R are the top-level administrators of the HSM, and N are the ones for the namespaces. To be held there as long as they need to be for setup purposes, and otherwise only basically have a list of operators. Those don't have any actual administrative rights on the HSM itself. So yeah, our first goals are with this literally to sign our sync databases, because that's the huge gap that we have currently. We do want to have like the easy wins of signing installation media and virtual machines. That's more or less easy to achieve as well. And then later on also venture onto signing packages, but in the context of a custom built service, not the way we do it currently. This is a work that is separate from this here, so, though, and other people are working on this currently. Our current next steps, because we have a few implementations already, is that we need to close up on some of the missing features that we have on the components. There's Signstar configure, which is to be used for configuration towards the NetHSM with administrative credentials. We have Signstar request signature that's used on the client side, and we have Signstar sign that is also used on the Signstar host itself to map the login users, etc., and create a signature. We still need to write an RFC for this, because Arch Linux for a couple of years now has an RFC process to actually deal with any changes to the distribution on that level. We need to buy a bunch of devices. It's not very cheap. Luckily, we have funds to do this. That's very awesome that we can use for this kind of endeavor. And we need to deploy it, which will also be a lot of fun, because we most likely have it standing around at heads now. So leads me to future work. As mentioned, there are some namespace features that basically allow to segregate certain operator users into bubbles of namespaces in which they can operate in their own little thing. And this is imaginable, for instance, for signing only towards packages or only towards sync databases, etc., and create a namespace for each of them. The cool thing is that administrative top-level users are not able to change these users. Only namespace administrators are able to do that later on. We still need to devise a configuration format, because we want to do these things in an automated fashion, ideally, to rebuild images and have these machines be updated automatically. we do need a payload format that allows us to do lightweight signing. What we've seen in other services like Sigul, for instance, that Fedora uses, is that they suffer from congestion on these hosts. So they literally have like gigabytes of traffic towards that host in seconds often, and that really slows things down. We want to kind of circumvent that. We do have a way of doing that, but it still needs like a spec for this format, basically. Yeah, the dedicated executables I've already shown in the previous slides. There's still an ongoing question and like brainstorm session around like how best to provide administrative credentials. We currently have arrived at like most likely using Shamir's secret sharing to have like an n out of m set of like parts of a secret that is used then to configure the HSM. These parts are given to individuals in the community and or in the distribution, which means that you need n out of m parts to actually do anything later on, to reconfigure the HSM and or to do anything literally with it, right? That allows us to not have like such a bus factor, and it allows us also not to rely on people, to be always around, etc. So the load is shared basically. We want to minimize the lifetime requirement of the administrative credentials also, because they are not needed most of the time. So if they're not needed, they shouldn't be existing on that host. The deployment is a huge issue still that needs to be tackled. We're currently looking into image-based A/B systems to fully automate that or be able to automate that. There are interesting new concepts that some of you might have used already, like system sys update, etc., that would allow us to automate some of the updates of that host transparently. That's great. And we want to also ensure that we can have like dedicated boot phases or phases of the host itself where credentials are available if they are needed, for instance, for reconfiguration. This needs like more in-depth investigation. If anyone has done this before, please reach out to me later. It would be very nice, because this is a very in-depth topic to literally have measured secrets basically in PCR values. There are still a few improvements to be made for the threat models, of course, around host security, also the physical access. What do we do when, Hetzner has someone just unplugging cables and then, whoops, oh, nice new host you have here. Please log in. What do we do with an administrator compromise? Also very important when it comes to, someone being able to put that host into rescue mode. How can we prevent exfiltration of administrative credentials? What do we do if n out of m people are held at gunpoint and told, hey, give me that shared secret now? There's no obvious answer to that, but it's nice to write it down, I guess. We still need a integration into our NetHSM log. We're currently looking into integrating with stuff like Recor because it exists already. Then we don't have to do anything with this by ourselves. And interesting ventures for the future are secure boot signing, because currently we do not have a signed shim. This is largely due to the fact that it's kind of not very great to have like one or two people holding that secret and doing that manually, etc. But the signing enclave is a very awesome place for that to happen, basically. The signing scheme is a bit more involved than just doing like an OpenPGP signature, unfortunately, because we also need to sign kernel modules, etc., with that. It's a bit more involved and a topic for future me or future us. Interesting other things that can be done and devised in the future are concepts like threshold signing. You're probably aware of the reproducible builds effort. Arch Linux has one too. We do have a few packages that are actually reproducible. That's nice. We could provide like signatures only if several hosts have actually reproduced that package, thereby gatekeeping packages to be having to be reproducible to even enter the repository. That would be great. Do you have any questions, maybe? Thanks. Oh.
Hello. You were talking about the 4i principle, but do you have redundancy in mind? So not only 4 eyes, but maybe 8 or more.
Yeah, absolutely. As mentioned in here, the seeding, but this also extends to actually reconfiguration. If we do this based on Shami's secret sharing, then this would mean that the secret is created, and the secret may be like actually a configuration item that holds several credentials for that HSM, is split up into several parts, and that is then given transparently to individuals. And n individuals basically would need to come together to form a working secret again in the end. So that would basically allow us to not have like this one person that has all the credentials in some local vault or something like that. That's basically where we want to end up in, ideally. Thanks.
Second question.
Yeah.
So if no one else is here, then maybe a second question.
Sure.
For the backups, do you have the same plan for the backups? So only maybe there are 2 people or more needed to restore a backup?
The backup is actually, that's a bit of an interesting concept that the HSM has. The backups are created using an unprivileged user, but they are encrypted using a predefined passphrase. That is part of the seeding phase. So it would be part of that shared secret, basically. So you even if you wanted to basically redeploy the HSM with a backup or from a backup, you would need n out of m people again to do that. Yeah. Yeah.
If no further questions.
Over there.
Oh, here.
Excuse
I
me,
also
please.
have one.
Yeah, sure.
Do you have any insight in the pricing for the Nitro HSM, by the way?
The price, I think it's not a 4-digit number, I'm afraid. 99 euros. Yes.
If you need to ask, you can afford, right? Yeah.
No, the NetHSM is literally like a 19-inch rack device, right? Yeah.
So it seems critical to make sure that signatures that aren't created or that shouldn't be created are caught early. And can you describe your plan for how you monitor the log and then detect unauthorized signatures?
Again, please, the question, maybe I didn't get it fully.
So you have a transparency log?
Yeah.
And all of the signatures are published in the transparency log?
Yes.
So if there's an unauthorized signature, how do you detect it?
Well, first of all, you can correlate like what you get in as metadata, like for instance, file names,
how do you do that?
Well, you have a monitoring service for that, but that's outside of the scope of this. Literally, this is just for signing. The detection is outside of the scope of this.
Okay.
Sorry.
Have you thought of a like say a backup strategy in terms of if the HSM fails, what do you do for the time until you have a new HSM to replace it? Because you wouldn't be able potentially for several days to create new security updates. How do you do that?
Yeah. Our plan is actually to have redundancy in that case, so not just by 1 but by 2. It's not very cheap, but Arch literally has the funds. We've been sitting on funds that we can't really use for paying people to work on stuff, but literally only use for hardware costs. And yeah, this is like the prime suspect of spending money basically for us. So yeah, I hope that answers the question.
So somewhat related to the previous question, what if, let's say, the NetHSM gets discontinued in 3 years or 5 years? And this tool seems to be closely tied to that, or is it more agnostic?
Yeah, currently this is tied to the NetHSM because it's like the only device that I'm aware of, at least, that actually has an open API to interact with and like an open operating system. But this is very much tied to that machine, of course, and we certainly hope that Nitrokey will thrive in the future. But at the same time, there's not much else we could do. We could potentially, resettle on other HSM devices, but personally, I would rather, work on something that actually is like open, because that has more benefit for all, I guess.
Okay, thank you.
Okay, many thanks for doing an interesting talk on a boring topic.
We still have some on a boring topic. Yeah, it is hopefully boring. I'm really hoping. I would like to still point out that the entire endeavor is basically run by Arch Linux related people. Arch Linux as such is not really like a funded thing, as in we're not tied to a company or something like that. We're looking for sponsors, so if you're interested also in a solution like this and want to maybe co-maintain or sponsor this effort, then please reach out. The slides are here. If you want to take a picture or whatever, there's plenty of links also in the slides to other things. Oh yeah, okay. And yeah, here's my contact info in case you want to reach out. Sorry.